Again, today I would say is one of the last hard lessons that we have. It is not a super important lesson in the grand scheme of things compared to what we do in other classes or what we do in other topics here with calc. I would also say it's the most pre-calc-like. So this is a half-life problem. A quick reminder with half-life, y equals AEKT. That's my formula. The y over here stands for your ending amount. The A is my starting amount. E is obviously A is a rate. It is the rate something is growing or decaying. And then the T is going to stand for time. All right, you've done this problem many times. You have forgotten, and it wasn't your favorite, I'm sure, when you did it initially. All right, so it says the half-life of potassium. Half-life is how long it takes for something to get cut in half. Okay, we're talking about radioactive particles, so things are leaving the particle and making it smaller and smaller as we go. The half-life of potassium is 1,350 years. If 20 grams are present now, how much will be present in 800 years? I like to visually understand what's happening here, so think about this. We got some ordered pairs. At time equals 0, how many grams do I got? 20. At time, 1,350 years, how many grams do I have? 10, because it's half-life. That's how long it takes to be cut in half. My question is, how much will be present in 800 years? So what is 800? Is that going to be my X or my Y? It's my X. It's my time. And that is the mystery number. If I can figure out what this is, I win. Look at it. It's multiple choice. What is the right? Which ones can we eliminate right off the bat? A and D. Why can't it be A? It's not getting bigger. It's getting smaller. My computer hates me. It's getting smaller. Go away. This is 20. It's getting smaller, so it can't be 25 grams. It's got to be somewhere between 20 and 10. Just guessing. What do you think the right answer is going to be? 13. Okay, we're going to guess that it's 13. We'll see if it's true. All right, so we're guessing that it's C. Let's see if it is C. We'll see if we got the right answer. Okay, again, here's how we started off here. A was our starting amount. That's why we put 20. Okay, E, K, T. I know what the time is going to be. My time is going to be 1,350 years, and then at 1,350 years, I'm going to have 10 grams. The first time through when we do half-life, you got to find the rate. You got to figure out the rate that it decays. So I need to solve that problem initially for K. If I want to solve that for K, Luke L., what am I going to do first? Yes, sir. Divide by 20, divide by 20. Cool, that's 1/2. I got to get K by itself. So, Evan, what else do I need to do? Take the natural log of both sides. That's going to cancel. Natural log of 1/2. Max, what else do I need to do? I want to get K by itself. Divide by 1,350 because I want to get rid of that stuff right there. That's going to be my K. All right, we can type that into our calculator. It's the natural log of 1/2 divided by 1,350. It's going to get me that ugly number right there. I don't really care what the number is. I'm just going to leave it in my calculator. Does it make sense that that is negative? Yeah, because that's my rate. Is my stuff getting bigger or smaller? So it's going to be negative. Okay, that's my value. I'm just going to leave it as the natural log of 1/2 divided by 1,350. That's what my K is. Once we discover what our K is, we're going to plug back in. We're still starting with 20 grams. This time, though, we want to know how much is left after 800 years. So that's why it's 800 there. I'm going to plug in my K. And if I type this in, it will tell me how much I'm left with. So 20e to the 800 times that number we just found, the natural log of 1/2 divided by 1,350. So all I got to do is type it in my calculator. 20e 800 times that number right there. I plug it in. I hit enter. Guess what? It's 13.2. We were able to guess beforehand. You might not always be able to guess, but we can always use it to help eliminate some answers. Questions on how we do a half-life problem? What we've done in the last 2 days of bell work are directly leading into what we're doing today. Okay, so the last 2 days of bell work I've set up today. This is what we did in today's bell work, a half-life problem. Everything that we just discussed is right there in your notes in case you need to look back at it again. But that's how we do half-life. Yesterday, we did this problem. We did dy over dt equals ky. This is a rate of change, a derivative of y is proportional to y. Proportional where if the k increases, the y is going to increase, okay, or vice versa. That is a rate proportional to y. If I wanted to find y, I would have to integrate. I would integrate both sides. I did all of that here. I separated, I integrated. I didn't solve for c, but I did solve for y. I got that thing right there. Cool. We did it yesterday. That is something you need to know, that when we integrate this thing right here, you get this thing right there. If you can just memorize that, it'll make all of the problems we do today substantially easier. Questions? All right, let's do a couple multiple choice here to start. These are easy, but it's understanding what's happening. Okay, there's not enough information in these problems to solve them. It is just which could be an expression. So we are just setting it up. A kitten weighs 85 grams at birth. During the first 4 weeks, its weight is given by the function w that satisfies this differential equation. So its weight in w satisfies this differential equation, where t is measured in days and k is some positive constant. Which of the following could be an expression of w of t? So they told me a derivative, dw over dt equals k times w. What could the expression for w of t be? They told me a derivative. They're asking for w of t. What would I have to do with this derivative of w to find w? Integrate it. We could separate. We could integrate. We could solve for c. We could solve for y, and so on. Or you could use your brain. What is this thing right here? When I find the antiderivative of it, what is it going to get me every time? Y equals AEKT. That is just something we need to understand. If we take the antiderivative of that setup of just a constant times a value, that is going to be the antiderivative. Okay. If you want to get fancy here, instead of y, technically it'd be w of t is equal to that. Okay, because we just integrated dw over dt. A stands for the starting amount. Do we know the starting amount? It's 85. We don't have enough information to solve it, but we know that that's going to be 85. Which one of these answers is going to be, which one could be an expression, A, B, C, or D? A is the only one that makes any sense. They didn't tell me enough information to figure out what K was, but it's a positive number because the kitten weighs more. That's my setup. Do I understand what we're doing there? We integrated, we plugged in, and worked. Try example 2. Same idea. This is just starting us off. Read the words. Try to figure out what the answer is going to be. Show me with your fingers. 1 for A, 2 for B, 3 for C, 4 for D. Hopefully it's pretty easy. We got dA dt. It's this guy right here. We are trying to find A of t. What would I need to do with dA dt to get just A of t? Integrate. And when I see this is a directly proportional relationship. Okay, I know that the antiderivative of that is going to be this. Y equals AEKT. I know that I start with 400. The only equation that makes any sense is A. Understanding that this right here becomes that right there is the key to everything we're doing today. Let's go to example 3. So now we're getting to more of a pre-calc setup, but we can see what we do. During a chemical reaction, the rate of change of the amount of chemical remaining. Okay, let's call the amount of chemical remaining the letter Y. That's the amount of chemical remaining. So the amount of chemical remaining is going to be Y. So the rate of change of the amount of chemical remaining. So what would we call that if we want the rate of change amount of chemical remaining? That would be the what of Y? It's the derivative because it's the rate of that. So dy over dt, that is the rate of change of Y. It is proportional to the amount remaining. That it is, so that means equals, proportional to the amount remaining. Well, what did we say is the amount remaining? What can we call that? That's Y. The amount remaining is Y. It's proportional just means that if I multiply it by a number, they're going to be equal to each other. Our number is K. It's just a constant. Okay? That phrase, the rate of change of the amount of chemical remaining, is proportional. The part that I underline there, the rate of change is proportional, means that. At time t equals 0, the amount of chemical is 12 moles. So I'm just going to write this down. At t equals 0, we got 12 moles. At t equals 4, the amount of chemical moles is 4. At what time t is the amount of chemical 3 moles? What is 3 going to stand for in this? Is that going to be my x or my y in my ordered pair? That's my y because that's an amount. I'm trying to find that mystery t. If I can figure out what this is, I win. Which one of these answers over here, A, B, C, or D, does not make sense? A doesn't make sense because look, this number gets smaller. These numbers are getting bigger, so it can't get smaller again. We got to pick one. We could probably guess. If you were to guess, what would you guess? Great. Guesses is great, okay? But we can actually do math, all right? This is a rate of moles. I want to know an amount of moles. What do I do with a rate to find an amount? Integrate it. We would separate. We would integrate. We would solve for C. We would solve for Y, and boom. Or we would know that if I integrate this thing right here, this setup, what is the antiderivative of this setup going to be? Y equals A, E, K, T. That is our setup. That's the calculus in this problem. If you just recognize it, it's really not any calculus. It's all pre-calculus. It's all algebra 2. Do we know our starting amount? Do we know what this is? It's 12. We start with 12 moles. The first thing I always have to do is find my rate. I have to know what my K is. I need to know what rate is it growing or decaying. That means I have to fill in a number for Y and T because the K is the thing I got to solve for first. What could I plug in for Y and T if I cannot have any other missing things? 4 and 4. That's what I'm plugging in. I got to plug in the ordered pair that I know. I'm going to plug in 4 and 4. I can't plug in this one because it's got a mystery number. I got to plug in the one that I know. That way I don't have any missing values. So I'm going to go a 4 right there and a 4 right there. The next thing I'm going to do is solve for K. Solve for K. Go. Yes, ma'am. Yes. Yeah. T is like the X because it's a dt problem. We're talking it with respect to time. Here we go. We are solving for K. If we're solving for K, Kalea, what did you do next? Yep. Divide by 12. Divide by 12. That goes away. That's going to give me 1/3. E to the 4K. Ella, what'd you do next? Good. Take the natural log of both sides. That's going to cancel that out. So we've got the natural log of 1/3. All I have left to do is divide it by 4. That right there is going to be equal to K. Once I figure out what my K is, I could type it into my calculator if I want to. I could take it right now and go natural log of 1/3 divided by 4. But I can just leave it right there. I'd rather not get a decimal and write down a decimal. Does it make sense that that's negative? Yeah, the chemicals are getting smaller and smaller, so it makes sense that we should have a negative right there. Let's keep going from there. Once I find my K, when we do problems like this, we're going back into this formula. Again, a second time. I now know what my K is. I just found it. Do I know what my starting amount is? It's still 12. That didn't change. E, I know what my K is. It's that natural log of 1/3 divided by 4. What other number should I plug in? I'm plugging in the number 3. What am I plugging in 3 for? Am I plugging it in for T or Y? Y, because I'm solving for T. I want to know at what time T. So that's going to be my Y value. I'm putting a 3 right there, solving for T. Do it. Get a T and then show me with your fingers what you got. We set it up. First thing we're going to do is divide by 12. Divide by 12. So that's 1/4 equals E to that K value times T. I already know what that K is. I'm going to not write it down. Then I'm going to take the natural log of both sides. And then to finish, I need to divide by that K value that we already found in our calculator. So in my calculator, I'm doing the natural log of 1/4, and I'm going to divide it by K. That is my K right there. I hit enter. Boom, my answer, 5.047. The answer is D. Question there on rate proportional. The rate proportional means Y equals AEKT. That's the key. Let's do the next one. Okay, a couple parts on this next one. Oil is being pumped continuously from a certain oil well at a rate proportional to the amount of oil left in the well. Most of the time, I would say that they will just leave it like this. When they're being mean, they will just tell you this part and they won't tell you that part. You need to see, oh, rate proportional, Y equals AEKT. Those two things in your brain should be the same. Okay, but here they gave me the formula where Y is the amount of oil left in the well at time T. Initially, there was 1 million gallons in the well. 6 years later, there were 500,000 gallons remaining in the well. It will no longer be profitable to pump when there are fewer than 50,000 gallons. Write an equation for Y in terms of the amount of oil remaining in the well. So they told me a rate, dy over dt equals K times Y. They told me a rate. They are asking me to write an equation for Y. What am I going to have to do with the rate to get me Y? Integrate it. We are technically integrating both sides, but we already know how to do that. We already know what the answer is. We could spend the time doing it, but why do it? What is the antiderivative going to be here? Y equals AEKT. There's my setup. We're trying to write an equation for any time t. So basically, we want t to be in our problem still, but we're trying to write an equation. A and B, what can I plug into this thing? 1 million gallons for what? Yeah, A sub 0, my starting amount. So that's 1 million. I always want to solve for K first. I want to know what that rate is. Do I know anything else? If that's what I'm trying to figure out, then I better have numbers for there and there. Is there something I could plug in for the time and the ending amount? 6. If I'm plugging 6 in there, what's this going to be? 500,000. Solve for K. We're solving. We're doing the same thing we've done every time. We're going to divide by 1 million. Divide by 1 million. That's going to get me 1/2 equals e to the 6k. Then I'm going to take the natural log. Then I'm going to divide by 6. That is what k is. The natural log of 1/2 divided by 6. Once I've got that, I'm right in an equation y. So that's this thing right here. Y equals, my A is 1 million. E, I know what my rate is. It's the natural log of 1/2 divided by 6. And I'm writing it for any time t, which means I'm going to leave a t right there. That is the answer to this first one. That is an equation. Now that I've got that equation, I can plug in any t I want, and it'll tell me how much oil is left in the container. Questions on A. Let's look at letter B. At what rate is the amount of oil in the well decreasing when there are 600,000 gallons of oil remaining? Include units in your answer. At what rate? What are we going to look at if we are looking for the rate? Dylan, what are we looking for? It's the derivative, right? We know what the derivative is. They told it to me. The derivative is this guy, dy over dt equals ky. Do we know what k is? Yeah, we just found it. It was that natural log of 1/2 divided by 6. Do I know what my y is? Yeah, my y is 600,000. Y stands for how much is remaining. It's 600,000. So to find the rate, I want to know at what rate. All I got to do is type it in. It's a really straightforward question. It looks tough, but if you think about it, it's just setting it up. Let's plug it in. Natural log of 1/2 divided by 6. That's my k. I'm going to just go ahead and type that in, and I'm going to multiply that by 600,000. Got enough zeros. Boom. There is my answer. 69314.718. 69314.718. I could put negative. I'm not going to put negative here because it's already saying at what rate is it decreasing, so it's already assuming that it's decreasing. So I'm just going to leave it as a positive number. What would my units be on that thing? Good. It is a rate. So it's dy. So what is my y measured in? Well, it's measured in gallons. Over dt, the change in time, and my time is measured in years. So it is gallons per year. Those are my units there. Last question. In order to not lose money, at what time t should oil no longer be pumped from the well? To solve this question, we're going back to that equation we found at the very beginning. Y equals that 1 million e to the natural log of 1/2 divided by 6 t. Talk with your neighbor. Solve that thing. The key here is when will the oil no longer be pumped from the well in order to not lose money? Anybody got an idea on what we need to do here? Austin, what'd you do? Good. We start losing money at 50,000 gallons remaining. So what'd you do with that? Good. That's our Y because that's the amount remaining. So 50,000 goes there. And that's going to be the setup. There's so many zeros. Natural log of 1/2 divided by 6. And then we're going to solve for t because we're trying to find that t. So all we're doing is just solving that question. Divide both sides by 1 million. 500,000 divided by 1 million is 1/20. E to the natural log of 1/2 divided by 6t. So in my calculator, I'm taking the natural log of 1/20th. And then I need to divide by my k value. And my k value is right there, that natural log of 1/2 divided by 6. Be careful when you type this in because there's a lot of places you could have made a mistake as you typed it in. But that's going to be my answer, 25.932. 25.932 gallons. Again, I took the natural log of both sides, and then I divided by that thing right there. I divide by that K, and that will tell me time. It would be years, definitely not gallons. That would be ridiculous because we were solving for T and not Y. Questions there? Cool. Try number 5 on your own. Think your way through it. See if you can figure it out. It's going to be very similar to example number 3 that we did. So if you're lost as to what to do, look back at example 3 for some help. See what you can do. Seems like we're doing pretty well. Again, the key to this problem is rate proportional. When you see that, it tells me this. I used V instead of Y because it's the volume. But the change in volume, the rate of the volume, is proportional to the volume. So it's K times V. When I integrate that, I get that guy right there. The first thing we always do is solve for our rate. So I started with 8 cubic feet. E, I'm going to figure out my K. I've got 2 variables. I can't have 2. So I'm going to plug in the things that I know. I'm going to plug in 12 and 5 because at 5 seconds, you've got 12 cubic feet. I'm going to solve for K. So divide by 8. So 3/2. I'm going to take the natural log of both sides, and I'm going to divide it by 5. That's what my K is going to be. So again, if you're struggling with typing this in, I would type that in. Natural log of 3/2, close those parentheses, and then divide by 5. That is my K value. Does it make sense that it's positive? Yeah, because the thing is growing. It's increasing. It says that right in the problem. That's my K. Once I've done that, then I'm plugging back into this guy again. I know what my K is. I know what my starting amount is. I'm trying to figure out what is the volume. So I'm looking for V when T equals 12. So that means I'm plugging in 12 up there. So all I need to do in my calculator is 8 E. That is not the letter E. There we go. 8E. And then that guy times 12. Type it in, hit enter, 21.169.